Hello, welcome back. My name is Melissa and I'm here with the Abbey Community School Society, ready to do our next science experiment together. Now, before we start, we should just go over our 3 very important science rules so that we can have a safe and fun time together. Now, our first science rule, do you remember what it is? Remember, we don't want to eat or drink anything during our lab today, just so we don't get sick. Our second rule is remember, if you want to smell something, remember to waft. That's a safe way to bring the smell up to your nose. And our third rule is make sure that you're not having your face right over top of your experiment, otherwise things can splash in your eyes. All right, so we're ready to get started. As you can see, our second experiment that we will be doing together will be a lava lamp. And we're going to make 2 different types of lava lamps together. Now, our goal for this experiment is to learn about density, what is density, and how an acid-base chemical reaction will help give the bubbles in our lava lamp today. Now, before we start, my table is science-friendly, so I don't mind if I get a mess on my table, but make sure before you start that if your table is a nice table, maybe you want to put some paper towel down or some newspaper, or even cover your table with a tablecloth. And that way we won't get any stains on your table from this experiment. If you don't have anything like that, you can always use a plastic container to put your bottle in. So to start, we are going to show you our supplies that we'll need today. So you should have, you might have a nice colored water bottle like this, or just a regular empty water bottle. We'll be needing 2 water bottles today. We will need some Alka-Seltzers, and Alka-Seltzers dissolve in water. We will need some food coloring, some baking soda, some vinegar, some vegetable oil, and some measuring cups. So I have a 1/4 cup and a 1/2 cup and just a big tablespoon so we can dissolve our solids in our liquids later. Of course, we also want some funnels, and this will be an easy way to get our water and our oil into our water bottle so we don't spill everywhere. All right, so we are going to start with our first water bottle. We want to unscrew the cap, and we're not going to use the cap from here on out, so we can put that off to the side. So we want to first add our vegetable oil. So we want to get our funnel and pour in our vegetable oil so that our bottle is half full of vegetable oil. Okay? So it doesn't have to be perfect, but just put in about halfway full. All right, that should be good. So if you haven't done so already, make sure you add your vegetable oil to your bottle. Now we are going to add our water. So we want to add only about a 1/4 cup of water. So you're welcome to use a measuring cup. So we pour in our water so that it's level to the top of our measuring cup. Now, if I put this in right now, I'm going to spill. So I am once again going to use my funnel. Okay, so go ahead now and pour in a 1/4 cup of water. All right, so what do you notice happened? I added the water in after the oil, but where's the water? It's on the bottom. Now, as I look in here, I don't think we quite have enough water in there. So we're going to add another 1/4 cup of water. So once again, take your measuring cup, and we are going to pour in a 1/4 cup of water. All right. So as we look at our bottle, what do we see? We see a lot of bubbles. We see that our oil is floating on top. This is when we can talk about density. So density is how packed together molecules are in a material. So if we think of a big rock, if we throw a rock into a lake, what is it going to do? It's going to sink, and that's because it is really dense. The rock molecules are stuck really close together, making it heavy, making it denser, so it sinks. But if we were to take a piece of paper or a feather and we throw it onto the lake, what's going to happen? That feather is going to float on top, and that's because its molecules are not as packed together. They're spread apart and they're lighter, and so it's less dense and it floats on top of the water. So the same thing happens with our oil. Our oil is less dense, it floats on top of the water. And you might think, why doesn't it mix together? That's because they have two different densities and they don't have the correct structure so that they can mix together. Okay? So now we are going to choose a food coloring. I'm going to choose blue. And when you're ready, drop in 10 drops of food coloring. And I want you to see where that food coloring mixes. Does it mix with the oil or does it mix with the water? All right, so go ahead, if you haven't done so already, add your food coloring and see where it lands. So my food coloring has gone through the oil and it has hit the middle between the oil and the water layer. So we want to give it a nice little swirl to see if we can mix that food coloring into our water. You might want to squeeze your bottle a little bit. Okay, so slowly our food coloring is going to drop down into the water and mix with the water because it's the same density as the water. All right, so now for the fun part. We are going to add our chemical, which is an Alka-Seltzer. So Alka-Seltzers are made of two main ingredients. They have sodium bicarbonate, which is a base, and they have citric acid, which is an acid. And when these two react together in the water, they're going to produce bubbles, or a type of gas. And we're going to see how many bubbles are created in this lava lamp, right? So we're going to take our one tablet and break it up into little pieces. The more little pieces you have, the more bubbles you will get. So I'm breaking mine into about 7 little pieces. When we're ready, we're going to add them to our bottle. Okay, so go ahead and do this step. You can pause the video and then come back to the video when you're ready. Okay, so we're adding in our Alka-Seltzers. They are sinking to the bottom. And what do you see? What's happening in your lava lamp? If you listen really closely, you might hear sounds coming from your lava lamp. So what is happening right now? What do you think? The Alka-Seltzer is dissolving in our water, and there's a chemical reaction between the acid and the base. And when they react together, they form a gas called carbon dioxide gas. And that gas is the same gas that we breathe out. So we breathe in oxygen and we breathe out carbon dioxide. Now, these bubbles, just like any gas or any type of air, they float to the top, right? If we think about hot air, right? A hot air balloon, we put hot air into that balloon, and where does that balloon go? It goes up into the sky. So the same thing happens. This Alka-Seltzer is making carbon dioxide gas. The carbon dioxide gas is less dense than water, so it floats up to the top of the bottle. When it reaches the surface, all of the carbon dioxide gas escapes through the mouth of the bottle and it leaves into the room. And now that droplet is just full of water, so it sinks back to the bottom. And it does this in a cycle, so the bubbles keep going up and down until our Alka-Seltzer has completely dissolved. Okay? So if you look at your bottle now, are any of the bubbles still moving? So it's slowing down a bit. So you can keep looking at your lava lamp and see how long it takes for the Alka-Seltzer to completely dissolve. And if you ever want to repeat this experiment, all you have to do is crush up another Alka-Seltzer and add it to the lava lamp, and it will do the same chemical reaction. Okay, now make sure if you do want to save your bottle for later, make sure that you don't add your cap until all the bubbles have released the gas into the air. So don't add your cap until it completely stops bubbling. Otherwise, if you add your cap and there's still lots of air and pressure in your bottle, what do you think might happen? It might explode. And we don't want oil to be exploded all over your house. So make sure you don't put the cap on until all the bubbles are done bubbling. Okay, so we're gonna leave that off to the side for now. For our next part of our experiment, we're going to try to make a lava lamp using a different chemical reaction. It'll have similar ingredients, but we're not going to use an Alka-Seltzer. We're going to use two household ingredients. One is vinegar, and the other is my baking soda. Okay, so that's a nice white powder. So we want to take our second clear, empty water bottle, take the lid off. We want to first add our baking soda. So we want to add about 2 tablespoons of baking soda. So I have my tablespoon measurement here. I'm going to take a dry funnel and put it into my water bottle. All right, I have measured out about 1 tablespoon of baking soda. It doesn't have to be perfect, so we're going to add it in there. And I said 2 tablespoons, so we want to add a little bit more. That should be good. All right. Now, if we notice, our first lava lamp has only liquids in it, so we can't start our lava lamp yet. We have to dissolve this baking soda in water. Okay, so we're going to pour in some water so that our bottle becomes about half full, or just under half full. All right. Now we want to dissolve that baking soda, so that means we want to shake it. But because we don't have a lid, we don't want to shake it up and down, so we're just going to swirl it to try and get that baking soda dissolved. All right, now it's time to add our oil. So once again, we take our funnel, and we don't have to add a specific amount of oil this time. We just have to pour until our bottle is about 3/4 full. Okay, so not half, but 3/4 full. Okay. Now we have our baking soda, which is a base, but we need our acid. So we are going to dissolve, or we are going to take our vinegar and add some food coloring to it. My vinegar is over here. We don't need too much. We just need about 1/4 cup. So I'm going to take my 1/4 cup measuring cup, fill it up, pour pour it into any type of glass. I just have my beaker here. Okay. What color should I choose this time? Let's do yellow. Okay. So you don't need too many. I'd say maybe let's do 6 drops. Now, once again, we want to mix that up, so we'll swirl our cup or our glass. And now for the fun part. We're going to see if our vinegar or acetic acid reacts with our baking soda, which is our sodium bicarbonate. Okay, so let's watch and see what happens. So you can pause this video now to make sure that you have mixed all your ingredients, and when you're ready, you can pour in your vinegar to your bottle. Wow, look, we made a little mess. That's totally fine. Sometimes science can be messy. So what do you notice in this lava lamp? I see a lot of bubbles. Do you see bubbles in your lava lamp? So those bubbles are coming from the sodium bicarbonate in your baking soda, and they're reacting to the acid in your vinegar to make carbon dioxide gas. And just like our first lava lamp, which mine is still bubbling. Is yours still bubbling? That gas is rising to the top of your bottle, and the carbon dioxide escapes out of the bottle into the room, and then it just becomes a yellow water droplet, and water sinks back down underneath the oil because it's more dense. And it keeps doing that cycle until all our baking soda at the bottom is dissolved. So let's look at it. So I see a lot of baking soda still undissolved. So you can keep watching your lava lamp experiment until all of that dissolves. And once it's dissolved, do you think it's going to still bubble? No, that's right. It'll stop bubbling once all that baking soda has dissolved. All right, so to remember this experiment, we talked about density. So remember, something that is lighter is less dense, like a feather, and something that is more dense or heavier, we can think of a rock. Or we can think, in this experiment, water is more dense than oil, so water stays at the bottom of your bottle. Now, just a safety note, you are welcome to keep these bottles at home because you can always redo the experiment by just adding more Alka-Seltzer or a little bit more baking soda and vinegar. But make sure that you don't add your cap on top until all of those bubbles have escaped the bottle. Okay. Once your lava lamp has stopped bubbling, we can put our lid onto our bottle. Now, before we shake it, we want to secure this lid. So with an adult supervising you, or if you're younger, have an adult do this for you. You can take hot glue gun and put some hot glue all the way around the lid just to secure it in place. And then you can even put some more tape around, masking tape or electrical tape. And then you're ready to tilt the bottle. So because there's oil and water in here and it's pretty messy, if it were to spill, we don't want to shake it up and down. So you just want to tilt it back and forth, and then you can look at all the bubbles that form, and you have a new lava lamp. So this brings us to the end of our second experiment together. I hope you enjoyed it, and hopefully you'll be back next time.